Hello everyone. Today I am going to start a new series on operational amplifiers. Now let us see the two types in which we can create the amplifier using an op-amp. One is without feedback and one is with feedback. Now without feedback, let's see the pin diagram of the op-amp first. Pin number 2 stands for the inverting terminal, which has a minus sign. Pin number 3 is the non-inverting terminal having a positive sign. Pin number 7 is connected to plus Vsat, which is the saturation voltage. And pin number 4 is connected to minus Vsat. Now I have two inputs V1 and V2, each given to pin 2 and pin 3. And I have an output Vout. Now whenever you see such a diagram, this means that the op-amp is in the open loop configuration. Without feedback is also known as open loop. Now the simple thing here is, if the voltage at the non-inverting terminal is greater than the voltage at the inverting terminal. That is, if V plus is greater than V minus, then my output will be plus Vsat. On the other hand, if my V plus, that is voltage at the non-inverting terminal, is less than the voltage at the inverting terminal, my output will be minus Vsat. This is op-amp without feedback. Now let's see the structure with feedback. Everything else is same, except here we see that we have a resistor connected from the inverting terminal to the output. This is nothing but known as the feedback resistance. Since the resistance is connected from the inverting terminal, we call this as negative feedback. Now there are two types of amplifiers in this configuration. One is the inverting amplifier and other is the non-inverting amplifier. I will discuss each and every amplifier separately, but for now just remember, whenever we have a loop-like structure here, it is known as feedback. Today I will discuss one very important gate problem on the open loop configuration, and tomorrow we will see one by one each amplifier. Let me start the problem. This is a previous gate problem. Now let's see what all is given. It might look very complicated, but it's actually very simple if you know the concept. They are asking, find the number of times the LED, this is the LED, in the circuit will glow. In the sense, how many times this LED will glow. This is the circuit. We have an input given at the non-inverting terminal. We have a voltage divider circuit with 7K and 3K resistance at the inverting terminal, and we have a transistor along with the LED connected at the output. Plus Vsat is 15 volts, plus Vsat is 15, minus Vsat is minus 15. Apart from that, we have been given a figure of Vi, the input voltage which is given at the non-inverting terminal. Now let's see. From the circuit, we have to first calculate what is V minus. We know that voltage is always calculated with respect to the ground. So, my V minus will be 3K by 7K plus 3K into 10. That will give me 3 volts. Now, it's a very simple fact that for the LED to be on, my transistor should be on. When will my transistor be on? Transistor is on when VBE is greater than 0.7. For VBE to be greater than 0.7, my Vout should be positive. So, for my Vout to be positive, V plus, that is voltage at the non-inverting terminal, should be greater than the voltage at the inverting terminal. Then my Vout will be plus Vsat according to the open loop configuration. So, V plus should be greater than V minus, then our Vout will be plus Vsat, which is plus 15. Now, from the graph of Vi, we can see that there are only 3 points, 1, 2 and 3, where my Vi is greater than 3 volts. That means only at these 3 points my transistor will be on and the LED will glow. So the answer is 3 times. 3 times my LED will glow in the following circuit. This is a previous gate question. I hope you are clear with it. Please like and share the video. Thank you.